Mr. Abbott, and here we are back again to the sun's path for Bellmore Lab. We were on step number 10, using the protractor to determine and record the altitude of the noontime sun for each season. Now, obviously, you could look at the model here, and the noon sun is here, and you have the protractor where each line is going up by 1 degree. The slightly longer line in the middle is going to be 5. So this is 20, 30, 25 in the middle. Looking at this, you're going up 25, 26. So to me, it's around 26. This one, you've got 50 degrees. So this appears to be between 50 and 49. Up here, we've got 70, 71, 72, 73, so this appears to be between my line for 73 and 74. So if I had to eyeball this, they would probably give you plus or minus 2 degrees for your answer if this was a free response on the Regents exam, but I'd say probably 49. Okay, this would be like 26 and a half, and I would get 72.5 degrees for this. The better way to do this, honestly, is by calculating the altitude of the noon sun, and you can do that based on your understanding of the seasons. Now, down here on the bottom, it's always easy to start off with the noon sun for the equinox. So, if we find the noon sun for the equinox, what you're going to do is you're going to take 90 degrees, which is the position at the zenith. So if I do 90 minus my latitude, that's going to give me the noon sun on the equinox. Okay, so for this example, it tells us our latitude is 40.5 degrees, so I do 90 degrees minus 40.5 degrees. Okay, I could even take out a calculator if I'm not good at math, and I might suggest that would be a good thing for you to do. So if I do 90 minus 40.5, when I do that, I get 49.5 degrees. And that's what I sort of said. It was between 49 and 50, so the altitude is 49.5 degrees. Now, once you've figured out the equinox angle, what happens is you get plus or minus 23.5 degrees for each season. Okay, every season, the vertical ray of the sun shifts between the Tropic of Capricorn, the Tropic of Cancer, okay, and the equator. So each season, the sun is going to appear to move either 23.5 degrees higher or 23.5 degrees lower. If they give you one seasonal path, you can figure out the other ones by knowing whether the sun gets higher or knowing the sun gets lower. So, if I wanted to do the summer solstice, which is 6/21, I would take that 49.5 degrees, I would add 23.5, which I think you know is the tilt of the Earth's axis. So I have 49.5, I add 23.5, and I get an answer of exactly 73 degrees. So the highest angle the sun ever gets for us in Bellmore is 73 degrees. I'm going to clear my calculator. In winter, instead of having a higher, longer path, in the winter we get a shorter, lower path. So for the winter solstice, or 12/21, I'm going to do 49.5 degrees, which is the equinox angle. This time I subtract the 23.5, So I do 49.5. I divide by, not divide, sorry. 49.5 minus 23.5. Okay, and then I would get 26 degrees. All right, so I would label this as a 26-degree angle. So the angles that you had, okay, were 26, 49.5, and 73 degrees. Now, if you look at that from 73 to 26, if I do 73 minus 26, that means the total change from the summer solstice to the winter solstice, this angle of the sun, that's the change in the altitude for a full year. The sun goes up or down 47 degrees between the seasons, which is why there is such a large difference in the amount of energy we get, whether it's summer or winter. Now, we have completed step number 10. The last thing that you have to do on the diagram is highlight. It says highlight the equinox path in yellow. So for the equinox path, the equinox, it always rises due east. In the morning, the altitude increases. You hit solar noon, and it would be setting due west. That path is exactly 12 hours. So that would be 180 degrees to go from east to west, and you would have a 12-hour length of daylight. So the yellow, the equinox path is the yellow. Summer solstice, they said use green, so I'm going to take my green highlighter. For the summer solstice path, I'm going to highlight it in green. Sunrise would be north of east, the farthest north of east for the year. All morning long in the AM, it would be going up. You hit solar noon, and then in the PM, it would be going down. So your summer solstice path on June 21st, you get the longest day of the year in terms of daylight hours. Okay, so that's what your summer solstice path looks like. Now, for the winter solstice, it says highlight the winter solstice in blue. So the winter solstice path, I'm going to highlight in blue highlighter. It's the only blue highlighter I could find, but it rises north of east. Okay, from sunrise to noon, the altitude increases, and then from noon to sunset, the altitude is decreasing. So the sun is on the horizon. You get the longest shadows around sunrise and sunset.